Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in last video we discussed the problems based on tangents and normals. Now students, in today's video we will discuss the topic called approximations and errors. And chapter remains same, it is applications of derivatives. That is our sixth chapter. Applications of derivatives. In this, there is one more topic called approximations and errors that we will discuss today. Approximations and errors. Very interesting topic. You can expect one question in your annual examination from this topic, as well as one question in CET also, or any competitive exams. So actually there are two different topics here, approximations and errors. So first, let us discuss what is approximation. The first is approximations. Approximations in the sense we will get a value. For example, if it gives a problem, find the approximate value of any quantity. Let us take square root of 25.2. Why do we call this is an approximate value for this? Why not an exact value? Because we know that if you ask find the approximate value of root 25, it is meaningless, because we know the exact root of 25 here, isn't it? We know the exact root of 25, so it has exact value. Its value is 5. So here it cannot be approximate value. But in case of this, you can ask find the approximate value of this quantity. The reason is, even if you are finding with a calculator also, you will get some decimals. And obviously all decimals we cannot accept. We can accept up to 4 places maximum. So here it is called as approximations. We will take the approximate value of this. But whereas in this case, it is the exact value. 5 is an exact value of this. There is no decimals. But here, because of this 0.2, we will get approximations. Then how exactly we will find the approximations? Student, here in approximations, we will take the definition of derivatives. In our first PUC, we studied first principle method. Derivatives by the help of first principle method. What exactly it says is, if suppose y is equal to f of x is a function, and if you are finding the derivative of this function, then we used to write dy by dx is equals to limit h tends to 0 f of x plus h minus f of x divided by h, isn't it? Where h is a small change in x, or here we can also call h is exactly equals to delta x, because h is a small change in x. Now here we said that h is tends to 0. H is moving towards 0. But it will never be equal to 0. The moment we said it is not equals to 0, and at the end we are anyhow substituting h as 0, so let us consider h is not at all equal to 0. Instead of telling h tends to 0 here, let me tell h is not equals to 0 because h is a delta x. H has some value, a minute value. So when I know that h is not equal to 0, let us remove this thing. If I remove this from the definition of derivative, then I will get dy by dx, I can write f dash of x. This I will remove. So if I remove this, what I will get? F of x plus h minus f of x divided by h. So let us do the cross multiplication here. If I do the cross multiplication, I will get h times of f dash of x is equals to f of x plus h minus f of x. So let me shift this negative f of x towards the left hand side. So I will get positive f of x plus h into f dash of x is equals to f of x plus h. So this is the exact formula to find approximations. To find the approximate value of any function or any quantity, we will use this formula where h is a small change in x-axis. F dash is derivative of that function, quantity. F of x is a real function. Let us discuss errors. Yes, student, it's quite possible. If you are measuring any quantity, we may do some mistakes. Even in fact, when drawing a line, it may not be exact measurement. Suppose if I tell you to draw the 7 centimeter line, well, measuring in the scale, if you draw like this, maybe if suppose 7 centimeter ends here, a dot is moved ahead. Dot is moved ahead, or a dot is left out. It stopped before 7. Isn't it? Or if you are measuring any quantity, some parts may left out, and some parts may added. So this kind of minute errors are quite possible. So that's why the other names of errors also let us discuss. It is errors are also called as change. Change, or it is also called as approximate change. Approximate change. These are the other names of errors. Changes. The quantities change. So how it will change? It will change with respect to the other quantity. Suppose if I said y is a variable, dependent variable, then the small change in y-axis is represented as delta y. And x is an independent variable, then the small change in x-axis is delta x. With reference to these things, the error is represented as delta y by delta x is equals to its derivative. That is derivative of dependent variable with respect to independent variable. So finally, here there are two approximations. One is on y-axis, other is on x-axis. He will give any one error, and other error he will ask us to find. In general, mostly he will ask us to find the change or error in our dependent variable. So here delta y is equals to dy by dx into delta x. Student, this is the formula we will use to find the errors. And here this dy by dx is derivative of that function or that quantity. at some particular point, at some x. Yeah, okay, let us remove this and make sure that it is at some particular point. Next, there are two kinds of error. The first one is relative error. The definition of relative error is delta y divided by y. Whatever the change in y-axis, that divided by y-axis. Y. Second is percentage error. Percentage error. That is equals to delta y by y into 100. Since it is a percentage, so we must multiply by 100 to the relative error. Then we will get percentage error. And here this formula is very important, and formula is delta y is equals to dy by dx into delta x. And relative error formula is, after finding delta y, we must divide by y, you will get the answer. Then percentage error is, to the relative error, we should multiply by 100. You will get the answer. After the basic concepts of approximations and error, let us move towards the problems. The first problem is find the approximate value of root 25.3. I'll read the question one more time. He's asking us to find the approximate value of the function root 25.3 using differentiation. Let us mention this also, using differentiations or differentiation. And here the given quantity is root 25.3. That is f of x plus h is equals to square root of 25.3. The moment I write f of x plus h is 25.3, then it declares that my x is 25 and h is 0.3. Then this is in the form of root. So if my x is 25, then my f of x is equals to root x. F of x is root x. And I know that in approximations, I must know its derivative. So let me find its derivative. Differentiate f of x with respect to x. What do I get? F dash of x is equals to derivative of root x is 1 divided by 2 root x. So let me substitute the value of x here. So 1 divided by 2 into x value is 25. So root 25. So it is 1 divided by root 25 is 5. So 2 into 5, it is finally 1 by 10. Or you can also consider it is 0.1. So I got the small change in x-axis. I know the value of x and its derivative also I know at x is equals to 25. It is 0.1. Let me write the formula and then I will try to substitute. Therefore, f of x plus h is equals to f of x plus h into f dash of x. Okay, friend, I don't know what is f of x value. I just know the function. So let me substitute here. So f of 25 is equals to root 25. So root 25 is 5. Because the function is root x. So if I put x is equals to 25 in the function, then I will get 5 is the answer. So finally, f of x plus h is square root of 25.3 is equals to, my f of x at 25 is 5 plus my h is 0.3 into f dash of x is 0.1. So finally I will get, it is 5 plus 0.3 into 0.1, it is 0.03. So final answer is 5.03 is the answer. So the approximate value of 25.3 is equals to 5.03. Find the approximate value of square root of 0.6 using differentiations. Find the approximate value of square root of 0.6 using differentiations. So here f of x plus h is given, that is the root of 0.6, and with this the approximate value of the nearer root of this is, let us consider 1. So this can be written as 1 minus 0.4, because if I remove 0.4 from 1, I will get 0.6. So with reference to this, I can write my x is 1 and h is negative here, minus 0.4. H is minus 0.4. Okay. So what is my f of x? Obviously, here the function is in the form of square root. So it is equals to root of x. Let me find at x is equal to 1. So f of 1 is equals to root 1. Answer is 1. So let us find the derivative of this function now. Differentiate f of x with respect to x. So what I will get? F dash of x is equals to derivative of root x is 1 divided by 2 root x. So it is 1 by 2 into root 1. Because the value of x is 1 here. So its root 1 is 1. So it is 1 by 2. Or we can easily write this as 0.5. So 0.5 is our derivative at x is equal to 1. The approximate value formula is f of x plus h is equals to f of x plus h into f dash of x. Let us substitute the values in this formula. So f of x plus h is 0.6 is equals to, what is f of x at x is equal to 1? F of x at x is equal to 1 is 1 plus h is minus 0.4. F dash x at x is equal to 1 is 1. So finally it is 1 plus into minus 0.4. So this is 0.6. Sorry students, I did a mistake here. Our derivative at x is equal to 1, it is 0.5, it is 0.5, sorry. So here f of x is 1, h is minus 0.4, and our f dash of x is 0.5. So how much it is? Plus into minus minus, it is 0. It is 0.2. It is 0.2. So the answer here it is 0.20. So 1 minus 0.20, we can write it is 0.80. So this is the approximate root of 0.6. Students, now let us go to the next problem. It is the third problem. Find the approximate value of 15 power 1 divided by 4 using differentiation. It is also called as fourth root of 15. Fourth root of 15. So let us write this. F of x plus h is equals to 15. Okay, this can also be written like this, because in your examination sometimes if you get like this, you should not get confused. This is the fourth root. 1 by 2 means square root, 1 by 3 means cube root, 1 by 4 means fourth root. So what is the nearer fourth root of this? Fourth root in the sense a number, if you multiply 4 times, you will get the root. What is that nearer to 15? It is 16, because 2 if I multiply 4 times, I will get 16. So that is, I will take here 2 into 2 into 2 into 2. 2 into 2 is 4, into 2 it is 8, into 2 it is 16. Yes. So here, this also be written as fourth root of 16 minus 1. Fourth root of 16 minus 1. Then definitely our x is equals to 16, h is equals to minus 1. And obviously our f of x is equals to x power 1 by 4, or fourth root of x. Okay, let us find its derivative at x is equals to 16. So this becomes differentiate f of x with respect to x. So what I will get? F dash of x is equals to f dash of x is equals to fourth root. X power n formula says that 1 by 4 x power 1 by 4 minus 1. X power n formula. Derivative of x power n says that n into d by dx of x power n says that n into x power n minus 1. So friend here, what we get? 1 by 4 as it is, x power, the LCM is 1 minus 4 by 4. So this gives 1 by 4 into 1 minus 4 is minus 3. That is x power minus 3 by 4. So this minus 3 by 4 power, I can shift it to denominator, then it becomes positive. We have dash of x is equals to 1 by 4 into 1 divided by x power 3 by 4. Then this power 3 by 4, I can also write like this, 1 by 4 into x power 1 by 4 whole cube. According to indices, a power m whole power m can be written as a power m into n. Now I know x power 1 by 4 value. This is my f of x. And let me substitute x is 16 here. At x is equal to 16, what happens? 1 by 4 into 6, 4th root of 16. 1 by 4 is 4th root, whole cube. So how much it is? 4th root of 16 is how much? 2. So 1 divided by 4 into 2. Actually, this 2 has cube here. 2 cube is 8. So 1 by 4 into 8. So finally it is 1 by 32. Now I can, okay, let us divide this 1 by 32. What is 1 by 32? First, 1 by 32 is something 0.03. Okay, 2 digit will take 0.03. So the formula says that f of x plus h is equals to f of x plus h into f dash of x. H into f dash of x. What is f of x? At x is equals to 16. Okay, at x is equals to 16, our function is 2. And I'll write it here. And f of 16 is 16 power 1 by 4. So answer is 2. So the function value at 16 it is 2. 4th root of 16 it is 2. So I will write here it is 2 plus h. What is h? H is minus 1. Okay. Into f dash of x at x is equal to 16. It is 0.03. Finally, I will get plus into minus, it is minus. So 2 minus 0.03. So what would be the final answer here? Then the final answer is 1.97. Okay, friends, now let us go to the next problem. The next problem is find the approximate value of 0.009 whole power 1 by 3. 0.009 whole power 1 by 3 using differentiation. So this time he has given decimals. So let us prefer decimals. So f of x plus h is 0.009 whole power 1 by 3. Students, as I said in the previous problem, power 1 by 3 means it is cube root. This can also be written like this, 0.009. It is like this. Now, what is the cube root? Nearer to this 9. Cube root nearer to 9 is obviously it is 8, and there are 3 zeros here. So obviously, student, this can also be written as okay, f of x plus h can also be written as cube root of 0.008 plus 0.001. Isn't it? We know cube root of 8 is 2, because 2 if I multiply 3 times I will get 8. But there are 3 zeros here, so this is 0.2. Now with reference to this, I can easily write my x value is 0.008 and my h is 0.001. So what is my f of x? My f of x is cube root of x. Also I can write x power 1 by 3. Both are same. Since let me find the function at 0.008. So I will write of 0.008, that is equals to 0.008 whole power 1 by 3. So student, its answer is cube root of 8 is 2 and there are 3 zeros, so 3 times I should multiply. I think it is 0. Differentiate f of x with respect to x. So derivative of cube root of x. F dash of x is equals to, again, x power n derivative. So it says that 1 by 3 into x power 1 by 3 minus 1. So finally this becomes 1 by 3 into x power. LCM is 3 in the power. So we get 1 minus 3 divided by 3. So it is equals to 1 by 3 into x power minus 2 by 3. So finally our f dash of x, since the power is in negative here, so we convert it to positive. So I can write this as 1 by 3 into x power 2 by 3. And write it properly. X power 2 by 3. What is the value of x here? The value of x is 0.008. 0.008. And since here power 2 by 3 can be written as 1 by 3 whole power 2. 1 by 3 whole power 2, that is cube root of 0.008 whole square. So this can also be written as the cube root of 0.008 is 1 divided by 3 into 0.2 whole square. So 0.2 whole square is 1 divided by 3 into 0.04. So finally our f dash of x is equals to 1 divided by 3 into 4 is 12. So it is 0.12. The derivative is 1 divided by 0.12. And here is this. So what is the formula for this? The formula is f of x plus h is equals to f of x plus h into f dash of x. This is the formula. In this formula, what is f of x? At x is equal to 0.08. Our f of x is 0.2 plus h is how much? H is 0.001. It is 0.001. What is f dash of x? F dash of x into 1 by 0.12. So this can be written as 0.2 plus 0.001 whole divided by 0.12. So this can be written as 0.2 plus 2 is 0.008. Okay, 3 digit I have taken here. Okay, so the finally it is 0.208. This is the approximate value of a function cube root of 0.009. Sorry, I will write it here. Cube root of 0.009. Okay, students, now let us go to the next problem. Find the approximate value of 3.968 whole power 3 by 2 using differentiation. Then this time is asking us to find the approximate value of the function 3.968 and it is whole power 3 by 2. That is square root of cube it is. First 1 by 2 is square root of this number and whole cube using differentiation. Let us write this. F of x plus h is equals to 3.968 whole power 3 by 2, or this can also be written as square root of 3.968 whole power 3. This is like this. Indices 3 by 2 can be written as 1 by 2 whole cube. The nearer exact root of this number is obviously 4. So this can be written as f of x plus h is equals to square root of 4 minus 0.132. If I take carry, it is 2 here, it is 3. Okay, it is 0. It is 0.032. Uh, 4 minus 0.032 is 3.968. This is square root and it has whole cube. With this, I can easily write the value of x is 4. H is equals to minus 0.032. I'll write it here. H is equal to minus 0.032. So what is our f of x? Obviously our f of x is square root of x whole cube. Let me find its value. At x is equals to 4. At x is equals to 4, my f of 4 is root 4 whole cube. What is root 4? Root 4 is 2. So finally it is 2 cube and I will get it is 8. 2 cube value is 8. After this, let me find its derivative now. Differentiate f of x with respect to x. What is its derivative? F dash of x is equals to derivative of cube root of x power 3 by 2 is x power 3 by 2 is 3 by 2 x power 3 by 2 minus 1. So what is the LCM here? 3 by 2, LCM is 2, 3 minus 2 by 2. So 3 minus 2 is 1. So it is 3 by 2 into x power 1 by 2. X power 1 by 2 is root. So it is 3 by 2 into root of x. X power half means it is root x. What is the value of x here? The value of x is 4. At x is equals to 4, my f dash of, okay, right, is 4 here. So my f dash of x is equals to 3 by 2 root 4. So 3 by 2 root 4 value is 2. So this 2 and this 2 gets cancelled. Finally, my derivative at x is equal to 4 is 3. So the function formula is f of x plus h is equals to f of x plus h into f dash of x. I got the value of function at x is equals to 4. It is 8. Okay. And right here, 8 plus h. My h is here. It is minus 0.032 into my f dash of 4 is 3. So if I subtract this, so I'll get 8 minus 3 2s are 6, 3 3s are 9. It is 0.096. So what is the final answer? 8 minus 0. So I'll write it here. 8.000, then minus 0.096. It is 4 and it is 0. This is 10, 10, 0. So answer it is 7.904. So student, the final answer for 3.968 whole power 3 by 2 is 7.904. Next kind of problems. These are the first kind of problems where he will give a quantity and he will ask us to find the approximate values. Now we'll go to the next kind of problems where he will give a function as well as a particular value of x. At that particular value, we should find the approximate value of the function. So now this time, find the approximate value of f of 2.01, where our f of x is equals to 4x square plus 5x plus 2. Student is asking us to find the approximate value of this function at x is equal to 2.01. This is the second kind of approximations, but formula remains same. Given f of x is equals to 4x square plus 5x plus 2. This is a given quadratic function. So here f of x plus h is what? F of 2.01. So this says that our x plus h is 2.01. If my x plus h is 2.01, then definitely my x is 2 and my h is 0.01. Okay. At x is equal to 2, I should find the value of this function. Then I should find its derivative also at x is equals to 2. So let me find the function value at x is equal to 2. So f of 2 is equals to f of 2 is equals to 4 into 2 square plus 5 into 2 plus 2. 2 square is 4 into 4. It is 16 plus 10 plus 2. So how much it is? 12 plus 18, it is 22. 28 it is. 12 plus 16 is 28. The f of 2 in this function, I will get 28. Let me differentiate this with respect to x. Differentiate f of x with respect to x. So what I will get? F dash of x is equals to 4 into 2x plus 5. 4 is coefficient as it is. Derivative of x square is 2x. 5 is the coefficient as it is. Derivative of x is 1 plus constant derivative is 0. So finally I will get it is 8x plus 5. What is the value of x here? The value of x is 2. Okay. F dash of 2 is equals to 8 into 2 plus 5. It is 16 plus 5. It is 21. 21. Now the formula is f of x plus h is equals to f of x plus h into f dash of x. So that x is equals to 2. The values are, what is f of 2? F of 2 is 28 plus h, my h is 0.01 and f dash of 2 is 21. So this will be 28 plus 0.21. So final answer is 28.21. So this is the approximate value of this function at x is equals to 2 and h is 0.1. And the approximate value of the function at 2.01 is 28.21. Let us go to the next problem. So it is similar to this. Find the approximate value of a function f of 5.001 where f of x is equals to x cube minus 7x square plus 15. Okay. Then we should find the approximate value of a cubic equation this time. It is a cubic equation at x is equal to 5.001. So let us follow the procedure of differentiation. Obviously using differentiation it is. It is using differentiation. Directly we cannot put x as 5.001 because we will mention using differentiation. Okay, given this time it is a cubic equation and it is x cube minus 7x square plus 15. So f of x plus h is f of 5.001. With reference to this, my x plus h is 5.001. The exact value nearer to this is 5. So with reference to that, my x is 5 and my h is 0.001. Next, let us substitute this value of x in this function. So f of 5 is equals to 5 cube minus 7 into 5 square plus 15. So what is 5 cube? It is 125. 5 square is 25 plus 15 as it is, no changes here. Then finally what do we get? 125 minus 7 5 is 35, 3 carries 14 and 3 is 17 plus 15. Yes, is it correct? 7 plus 35, 3 carry 14 plus 3 is 17. Yes, correct. Now, if I add these two quantities, I'll get 140 minus 175. So my f of 5 is 140 minus 175. It is minus 35. It is minus 35. Just a minute. Yes, it's correct. Now let us find its derivative with respect to x. Differentiate f of x with respect to x. So f dash of x is equals to 3x square minus 7 into 2x plus 0. So this is equals to 3x square minus 14x. At x is equals to what? X is equals to 5. F dash of 5 is equals to 3 into 5 square minus 14 into 5. 5 square is 25 into 3. It is 75. You can do the calculations quickly. 3 points of 15 carry 675 minus 14 into 5. It is 70. Answer here it is 5. So my f dash of x at x is equal to 5 is 5. I know x, I know h, I know f of 5 as well as f dash of 5. Now let us substitute everything in the formula. What is formula says? Formula says that it is f of x plus h is equals to f of x plus h into f dash of x. This is equals to, what is f of x at x is equal to 5? It is minus 35 plus plus the h is exactly here 0.001 and f dash of 5 is 5. So the final answer here is minus 35 as it is plus 0.005. So the final answer is minus so it is 5, 9, 34 minus 34.995 is the answer. So the final value of the approximate value of this given cubic function at 5.001 is minus 34.995. Student, this is about the problem based on approximations. Similar problem you will get, and I hope you will understood the concepts of approximations. Now students, let us move on to the next concept of the same topic called errors. Errors. As I already discussed, there are two kinds of error. One is relative error, other is percentage error. And the formula we discussed here is delta y is equals to dy by dx into delta x. This is the formula we are going to use in errors. And let us try to solve some problem based on this formula. So let us take the first problem of error. Find the approximate change in the volume V of a cube of x meters caused by increasing the side by 1%. So this problem is related to the rate of change of quantities concept, and I will read the problem. Find the approximate change in the volume of a cube. Volume of a cube. They mentioned a cube and it is volume. We know in rate of change of quantities we studied what is the volume of cube, and is it x meters. In cube edges x meters caused by increase in the side. The sides are increasing by 1%. So solution, the side is x meters, x is increasing by 1%. So let me take the volume of a cube is side cube, and this he has given x is x only, side is, but delta x is 1%, that is equals to 0.01, 1 by 100. 1% means 1 by 100, and that is 0.01. Differentiate V with respect to x. So dV by dx is derivative of x cube is 3x square. Now dx side by 1%, it is into x. X into 1%. So now student, I got the derivative of V with respect to x. Now delta x is there, 0.01 into x. So the error is delta V is the error we are finding. The approximate, how can we identify whether it is an error or not? See, here he has used the word approximate change. I clearly said directly he may not ask error, he may ask different ways, and the other way of asking error is approximate change, or the other name of error is approximate change or change. And obviously whenever we said it is a change, it is y2 minus y1. Changing. Y is shifting from 1 to 2, or changes means y2 minus y1 or y1 minus y2. But whenever we get a word change, it is considered as delta V. It is changing. It is error. So delta V is equals to dV by dx into delta x. What is dV by dx? It is 3 into x square. And delta x is 0.01 x. So finally, my delta V is equals to 0.03 x cube. X cube. Now let us go to the next problem. Find the approximate change in the surface area of a cube of x meter caused by decreasing the side by 1%. Decrease the side by 1%. Okay, student, it is quite similar to the previous problem because it is also related to a cube. It is related to a cube, and again he used the word approximate change. Approximate change means again change in the surface area. So let us see what are the things he has given. He is asking us to find delta S, where S is the surface area of a cube. Surface area of a cube is 6 into x square, 6 into side square. Okay, side is x only. So decrease is said. He used the word decrease. And in rate of change of quantities, we studied whenever we get a word called decrease, we should put a negative sign. This is very important. So side is getting decreases by 1%. So it is 1 by 100. That is minus 1 by 100 into x. So delta x is equals to minus 0.01 x. The next is, let us go to the derivative of this surface area with respect to x. Differentiate s with respect to x. What do we get? ds by dx is equals to 6 is the coefficient as it is. Derivative of x square is, it is 2x. Finally, we will get 12x. So, what is the formula we will get? Delta S is equals to ds by dx into delta x. This is equals to ds by dx is 12x. Delta x is minus 0.01 into x. Now delta s is equals to minus 0.12 x into x is x square. So student, this is the approximate change in the surface area of a cube whose side is x meter and decreases by 1%. So there is a negative sign here. If the radius of a sphere is measured as 9 meter with an error of 0.03 meter, then find the approximate error in calculating its surface area. So this time has clearly given everything, and again it is related to a sphere. Means it is related to previous problem, and this time he has said that the radius is measured as 9 meters. Okay. Solution. Okay, radius is given. It is 9 meter with an error in radius. Okay, delta R, we did an error, that is 0.03 meter error we did. Okay, then if this is the error and this is the radius, then find the approximate error in calculating its surface area. Delta S is asking us to find. And what is the formula to find surface area of a sphere? Okay, students, the formula to find the surface area of sphere is 4 pi r square. 4 pi r square. So first let us differentiate this s with respect to r. Differentiate s with respect to r. So what happened here? ds by dr is equals to 4 pi, coefficient as it is. Derivative of r square is 2r. Then it is 2 into 4, it is 8 pi r. The value of r is 9. So ds by dr at x is at r is equal to 9 is 8 pi into 9. 9 into 8, it is 72 pi. So the approximate change in the surface area, that is our delta S is equals to ds by dr into delta r. So this is equals to and ds by dr is 72 pi, okay, into delta r. Delta r is somewhere here 0.03. So 3 to the 6. Okay. So our delta S is equal to 0.03 into 72. 3 to the 6. 7 3 is 21. 2.16 pi is the answer. So student, the approximate error in calculating surface area of the cube, surface area of the sphere is 2.16 pi when its radius is 9 meters. Okay, the next problem is the radius of a sphere. The radius of the sphere is measured as 7 meters with an error of 0.02 meters, then find the approximate error in calculating its volume. Then in this problem, he said that the radius of the sphere is measured and it measured as 7 meters, but while measuring we did an error of 0.02 meter. If this is the error we did, then he is asking find the approximate error in calculating its volume. Volume of a sphere. Solution. What is given? Radius is given. It is 7 meters, and error in radius is given 0.02 meter. He is asking us to find volume in error in the volume, that is delta V. The volume of a sphere formula is V is equals to 4 by 3 pi r cube. 4 by 3 pi r cube. Okay, then let us first differentiate this V with respect to R. Differentiate V with respect to R. How much it is? V by R is equal to 4 by 3 pi. It is a coefficient. Now derivative of R cube, it is 3 into R square. Okay, now numerator and denominator gets cancelled. So you get 4 pi R square. What is the value of R here? 7. So dV by dr is equals to 4 pi 7 square.